Hello everyone, welcome to Trinity Tech Academy where we learn, build and aim. My name is Samuel and I'm going to be the course instructor for this practical introductory course to Python programming. In this first module, we're going to look at the basics, and in this very class, we're going to talk about some key concepts about programming. Let's begin by talking about types of knowledge. Knowledge can actually be represented in two ways: declarative knowledge and imperative knowledge. Declarative knowledge are statements of facts, while imperative knowledge has to do with more of a kind of recipe or how-to. When we are talking about declarative knowledge has to do with describing what should be done, and it focuses more on the result or goal, and it is usually easier to understand declarative knowledge. Whereas in the other hand, imperative knowledge has to do with more of describing how to do something. Remember, declarative knowledge describes what should be done, while imperative knowledge describes how it should be done. So they are two very different things. Imperative knowledge focuses more on the procedures or the steps. Generally, programming is about writing recipes to generate facts. That means we're going to be using more of imperative knowledge when we write computer program code. Look at it this way. When I say list out all even numbers, you do not have to go about explaining every step it takes. You just list out even numbers, possibly let's say from the range of 1 to 10. So you have 2, 4, 6, 8 and 10. That is what declarative knowledge is all about. But in the other way around, when we are dealing with imperative knowledge, we need to go about explaining every step it takes to come about each even number. Starting from the range of 1 to 10, starting from 1, we need to check each number. At each number or each point, we need to divide that number by 2. If the remainder of that division is 0, then we know that number is an even number. That is what imperative knowledge is all about. Now, generally programming is about writing recipes to generate facts, and we're going to be using imperative knowledge, just like we've described, to represent or to write our computer program code. Next up, we're going to talk about algorithms. Algorithms has to do with steps, flow of control, and when to stop. What does this mean? Let's define an algorithm. An algorithm is a finite step-by-step procedure used to solve a problem or perform a particular task. A finite number of steps used to solve a problem or perform a task. So there are 5 main features of an algorithm. 1. Every algorithm has an input. That means the data must be supplied. Every algorithm must have an output. It must have a result. Every algorithm must be definite. That means it must be clear. Every step must be spelled out accordingly and clearly. Every algorithm must be finite. That means it must have a point at which that algorithm will stop. And lastly, every algorithm must be effective. That is, it must be practical. It must be something that can actually be executable. Now, this is a simple everyday example of an algorithm making a cup of tea. What are the steps in making a cup of tea? 1. You boil your water. 2. You put a tea bag in the cup. 3. You pour hot water. 4. You add sugar to it. 5. You stir and you serve. Now, looking at this example, you find out that each or all the features of an algorithm has been met by this example. Our input are, our data are water, the tea bag, the sugar, and it also has an output, that is the tea after it has been prepared. The example is also definite. That means you must go from one step to another, from boiling water to putting the tea back in a cup to pouring hot water on it, adding sugar, stir and serve. You can't move from boiling water to maybe adding sugar, or maybe you move from boiling water to stirring and serving. No, you have to go from one step to the other. Talking about aspects of languages, we're going to talk about primitive constructs. Primitive constructs are the basic building blocks of a programming language. In Python, which is going to be our programming language of consideration, we are going to be talking about numbers, strings, operators, keywords, etc. These are primitive constructs. These are the building blocks. These are the things that actually make up our program code. So we call them the primitive construct. Then we'll look at syntax. What are syntax? The syntax are simply the rules governing how we write our program code. It is just like grammar in English language. Next thing is the semantics. The semantics has to do with the meaning of our program code. Lastly, we are going to be talking about errors, which can also be syntactic errors or semantic errors. Everything in Python programming is considered to be an object. For now, just look at this the way I will explain it, and subsequently when we continue to dive into the course, you're going to understand what all this means. But the object, generally, we have two types, which can be scalars or non-scalars object. Our scalars object include things like integer, float, boolean, and non-type, while non-scalars include list, dictionary, and tuple. In a simple way, scalars stores a single value, whereas non-scalars objects are those objects that can store multiple values. A statement is an instruction that performs an action. For instance, when I ask, "What is your name?" you respond by telling me, "Your name is Samuel." That is a statement. It's a basic statement. In the other way around, we have expressions. Expressions are a combination of objects and operators. Remember, we say that objects can be scalars or non-scalars. Now, when you combine objects and operators, it results mostly into an expression. For instance, when I have two objects of type, or two objects which are scalars, let's say integers 1 and 2, and I now add an operator to it to form an expression such as 1 plus 2, right? I have 1 plus 2. When I give this as an instruction, or I ask, "What is the result of 1 plus 2? You need to actually carry out a computation to give me the result or the answer I need by adding or summing 1 plus 2, which is 3. So this is an expression. It's different from a statement, right? So we're going to be writing statements and expressions in our program code. And lastly, we're going to be talking about operators and operator precedence. We have different type of operators. We have arithmetic, relational, logical operators. Operator precedence has to do with determining which operation executes first when you have a kind of compound expression.